What I was saying at the end of class. There's two things we sometimes use to count things: permutations and combinations. A permutation order matters. The order of the objects matter. Like for instance, if you knew your code had the numbers 8, 5, 6, 7 in it, and you couldn't remember what order they were in, then your code wouldn't work on like your ATM. If it's 8, 6, 5, 7, you better be able to type in 8, 6, 5, 7. It's not just a group of numbers, the order would matter. A combination order doesn't matter. Okay, so if I have, what I mean by that, if I have like 3 students, A, B, and C, or let's give them names because this may be easier to talk about. So 3 teachers. So if you say, oh, in the math department there's Miss O.D., Miss Arcan, and Miss Z.C. And then someone said, then someone else walked up in a tour or something and said, oh, who are name 3 teachers in the math department? And you thought, oh, I'm going to name different ones. So it's Miss Arcan, Miss Z.C., and Miss O.D. Well, you didn't just name 3 new people. The order didn't matter. It's just a group of teachers. It's a group of people. If you say on the softball team, we have like Ellie and Sam and Susan, let's say, are on the softball team. And then that's just the team. I don't get a new team if I say Sam, Ellie, and Susan. That's not a new team. Combinations order does not matter. It's usually a group of people, a team, a squad, a committee, where, you know, if your mom said, who'd you go out with tonight? And you said Sam, Ellie, and Susan, it's not a new group. If then you say, oh yeah, but I was with Ellie, Sam, and Susan. That doesn't matter. All right, permutation, the order matters, is usually like a code or like officers in a club. Like if it was standard, like for instance, we have to fill out these Google forms for Dr. Califano, and it'll go like president, vice president, secretary. And so if my president was Ellie, and my vice president was Sam, and my secretary was Susan, pretend like that says Sam and Susan, the order definitely matters. Like, I can't just go, oh, well, it's one of these 3 girls. If they want it in a certain order, and if I'm going to list them and it's implied that it goes president, vice president, secretary, or if you're going to take pictures for the yearbook in this way, where you have president, vice president, secretary going from left to right. Even when people go in and sit at certain places, the order matters if they're at like the head table. And so permutation, the order matters. That's a lot of times in codes. All right, so let's look at this. We'll do kind of a short group of letters. Suppose I have 4 letters. Those aren't letters. Suppose I have 4 letters like A, B, C, D. And let's make 3-letter codes. A, B, C, A, C, B, A, B, D. A, D, B would be a different code or a different group if this is president, vice president, secretary. Let's see, A, C, D. Have I done that one? And A, D, C. So it looks like there's 1, 2, 3, 4, 5, 6 ways with the A. Let's see what happens with the B. I could make a code of B, A, C, B, A, D, B, C, D, B, D, C, B, have I done A, C, I've done B, A, D, B, D, A, B, C, oh, I didn't do B, C, A, and I'm missing another one, B, A, D, B, D, A. All right, so it looks like that there's 1, 2, 3, 4, 5, 6 ways with either of the 4 letters. And so like we did in class, it looked like there's 24 ways to do this, which is really tedious. And so if I'm doing codes, these are different codes. The order does matter, which, by the way, it's interesting. A permutation, the order does matter. A combination, the order does not matter. It's just a combo of things. So actually in our English language, combination, we misuse it. If we talk about your locker combination, and you go, oh, my locker combination's like has the numbers 1, 4, and 7 in it somehow. Well, it really matters if you go 147 or 174 or 741. And so really a locker combination is a locker permutation. But anyway, this was tedious. I don't want to do this, especially can you imagine if I let you use all 26 letters in groups of 3. Then I would be going A with B and Z, and it would take forever. All right, so what's our counting? We're learning to count. So this is 4 letters in groups of 3. All right, so I would write that in our notation like this. It'd be a permutation of 4 things 3 at a time. All right, when you do that, you get 4 factorial over 4 minus 3, which is 1 factorial. So it gives you 4 times 3 times 2 times 1. And that gives you 12 times 2, 24. And so this is great if you have 26 letters in groups of 3. All right, so this is great to know how to count. I would probably never be able to list these out. The answer to this would be 26 factorial over 26 minus 3, or 23 factorial. And we'll practice that in a minute. You could type it into your calculator or do it by hand and multiply it out on your calculator. Just give me 26, 25, 24, 23 on down, cancels out. All right, now let's look at the letters A, B, C, D, and let's pretend like these are students, and let's do groups. All right, so I'm going to put these 2 people in a group to work on something. Is this a different group? No, they're just in I paired these 2 students up. So that's not a new group. Oh, I want them in groups of 3, sorry. All right. So say I put these in a group together, A, B, and C, and I go, y'all are going to be in a group. Well, it doesn't matter if I go A, C, B, or, where's the other one, B, A, C. Those are all the same group. But I could leave out B or C and put a group of A, B, D. But this is not a new group. You'd say, oh, you already put these 3 people together, like trying to think of people, Arabella, Bella, and like Daniela. This would not be a new group. It'd be the same 3 girls. And there's one right here. All right, but we could leave B and E out and put A, C, D, but this is not new. And A, right, so we have this one, A, C, D, and do I have another? I should have another if I added right. Oh, I didn't list them all. So I didn't finish to the end. But ADC would be the same as CDA and CAD and all of those. That would not be new. All right, now what if I have BCD? BDC is not new. BCA, I think I already have right here. BDA, BDA, I already have right here. All right, so far I only have, so with my A's, I could put them with B and C. I could put them with B and D, or C and D. What could I do with B? I could put B with C and D. Or what if we leave out, is there anything else I can do with B? I can put B with C and D. What if I put B with A and C? I've already done that right here. All right, so are there any more? I could put C with D and A. Do I have a CDA? I have it right here. I've already put those people together. All right, so what's the quick way to do this if you want to go, okay, I'm going to do a combination where order doesn't matter. So it's a combination of 4 things 3 at a time. To do that, you put this on the top, You still subtract these like you did with a permutation. 4 minus 3 is 1 factorial. And then you add this on 3 factorial. So it gives me 4, 3, 2, 1 over 1, and then 3, 2, 1 cancels out, and there are only 4 ways, so I got them right here. All right, so your notation goes like this. Our permutation can be written like this, or sometimes you'll see it written like this, where this means this is the number of things, like you have 10 people, and you're going to elect officers, so the order matters. That's in groups, and 3 officers, I'd say in groups of 3. So this will be a permutation of 10 things 3 at a time. Permutation implies that order does matter. The order does matter. So it matters how I choose the people, or call them up to the front, or seat them at a table in order of president, vice president, secretary. Okay, so this one, we see this notation mostly in our book, but you might see this in other places. All right, so if I use this notation, I'm going to go, or either one means to go 10 factorial, and then 10 minus 3, which is 7 factorial. And it'll count all the different orders that you can get. And then you can multiply this out. This looks like it's going to be 720. And so it's a whole lot better than listing them all out and counting them. Let me show you how to do that on your calculator. Where's my calculator? Oh, I must have closed it. All right, so I'm waiting for it to open. All right, the ways you might see a combination of 10 things 3 at a time means, like if I named I don't have 3 children, but if I had 3 children and I named my 3 children, it doesn't matter what order I name them in, it doesn't make them different children. But if you asked who was the oldest, to youngest, then the order would matter. All right, so still waiting on my calculator to open. But what you do here is you start it off like a permutation, 10 things 3 at a time. Subtract 10 minus 3, just like you do up here, and you get 7 factorial. But then you also go back and grab that 3 factorial. And there should be less ways. That would be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 cancels out, over 3, 2, 1. And we'll get that number in just a minute. It should be 720 divided by 6. Might be 120, but real, you get 720. Or you could do this. You could go, you got to put this number in first, 10. And then you could go to math, go where your factorial is under probability, and push permutation. And we're doing them 3 at a time. And we'll validate that I did my math right, so it's 720. All right, if you want to do a combination where you're just given a group, don't forget to put your number in first, and then math. Go to where your factorial is, but choose combination 3, and then 3 at a time, and it should be 120, which is what this number is right here. All right, I'll show you when you're allowed to use your calculator on your homework and when you're not. Another thing about combinations, you might see it written like this. You might also see it written like this, and you've even seen it written like this. Notice how our information we're learning is melded together, and that this is really what we use in the binomial theorem, where these two numbers 10 factorial, and you have a 7 and a 3 factorial on the bottom as a combination. So what this extra number does here is it factors out, it pulls out all the different ways that the order doesn't matter. All right, so let's look at some Delta Math homework that you're going to have, and then some book homework. All right, so there are 9 people on a basketball team. The coach needs to put in 5 people. And the order doesn't matter. So how many, if you're going to only get 5 people out of 9 people and go in there on the court and play basketball, that's a combination. So I'm going to have the combination of 5 players. I'm going to have a combination of 9 players, 5 at a time. If I show my setup, that's 9 factorial over 9 minus 5, which is 4 factorial, and go back and grab that 5 factorial. And once you do your setup, you can have 9, 8, 7, 6, 5, 4, 3, 2, 1, 4, 3, 2, 1, 4 and 2, 8, 3 goes into 6 2 times. If I did that right, I get 126. So let me see. So this would be 126. Submit answer. Okay. However, you also have this option of 9. Oh, notice how they wrote their notation. All right, so if you wanted to do the combination, I don't know why I got a new tab. If you want to do your combination on the calculator, if that's a time that I'm accepting it, you could go, I want 9 players. You've got to decide yourself if it's a combination or a permutation. It's a combination because you're just going to send 5 people in, 5 at a time. And that gives you 126. Okay, let's look at a new problem on Delta Math. Alright, so a principal would like to assemble a committee of 7 students from 11. And it's just a committee, so that's a combination. A pizza shop has toppings available: pepperoni, peppers, sausage, mushrooms, olives, onions, anchovies, and pepperoni. How many different ways can a pizza be made with 2 toppings? So you have 1, 2, 3, 4, 5, 6, 7. Girls, this is a combination. Can you imagine if you went into a New York pizza place and said, I want, they said you could get 2 toppings, and I say, I want a pizza with onions and olives. No, I want a pizza with olives and onions. That's not a different pizza. That's a combination where order doesn't matter. A lock has a code of 5 numbers between 1 and 20. If no numbers in the code are allowed to repeat, how many different codes could be made? Now I have a code. That's a permutation of 20 numbers, 5 at a time. So I would have a permutation of 20 numbers, 5 at a time, because the order does matter. That would be 20 factorial over 20 minus 5, which is 15 factorial, which you could, if a calculator's allowed, you could type it in like this, or you could type it in factorial. Remember, if you have more than one number on the bottom, to use parentheses, or you could like do your canceling 20, 19, 18, 17, 16, 15 on down, cancels out. But then you're still probably going to want your calculator to multiply it out. So let's do this one on our calculator. It's a permutation because it's a code of, you got to put your 20 in first, math, go to probability, and be sure you pick permutation. And we're doing codes, and it's going to be a lot. So 1,860,480 codes. There's a lot of codes, which you need if you are a banker, okay? So I already forgot the number. So 1860480. 1860480. And so you've got a lot of codes there. All right, then in the book, you'll have these. Evaluate using the formula. So on 27 through 32, I want you to actually show me the setup. Like for instance, if you had one that was a P5, 2, I would want you to see you go 5 factorial over 5 minus 2, which is 3 factorial, and go 5, 4, 3, 2, 1, and get 20. Okay? So show me your setup on those. On these, it says use a graphing utility. So grab your calculator and use your P button. And here's your combination, same thing for these. So you'll have these 10 problems right here that go really fast, and these 10 problems right here that go really fast, and then a little bit of delta math, some delta math that I was just showing you a second ago. Oh, one more thing. Suppose you have a P5, 5. That would be 5 factorial over 5 minus 5, which is 0 factorial. Oh, sorry, you couldn't see that. P55 would be 5 factorial over 5 minus 5, which is 0 factorial. 0 factorial is defined to be 1. So this would just be 5 factorial over 0 factorial would be 5, 4, 3, 2, 1 over 0 factorial, which is just 1. And so you would get this entire number, which is, I think is it 120? 120, I think. Because this is 24 times 5. Yeah, so that's 120. But I wanted to make sure you knew what 0 factorial. 0 factorial is defined to be 1. Now, how would that work with a combination? A combination of 5 things, 5 at a time, would be 5 factorial over 5 minus 5, which is 0 factorial. Go back and grab this 5. And that gives you, this is 1, and 0 factorial is 1. So there's one way. That means if I have a group of 5 students, and I'm going to send 5 students to go do something for me. Once I send you out of the room, there's only one way I can put that group of students together. Is say, hey, 5 students, let's do breakout rooms, and we're going to have 5 people in each room. Then there's only going to be one room, okay? So I'll post your homework, and have a good weekend.